Hello everyone, welcome to CABuilder version 1.4.1. Let's explore what's new. We'll begin with some changes to the user controls. You may now drag dimensions out of the way to avoid overlapping other objects. For example, if I were to put a horizontal dimension in between these two cabinets, that dimension would be, let's try again, between, let's say, the corner of this cabinet and the corner of this cabinet. That dimension could overlap other objects and may not be clear what's going on here. So you can now click and drag these to drag them out of the way, perpendicular to where the measurement marks are. And this works with both horizontal dimensions as well as vertical dimensions, as well as point-to-point or diagonal dimensions, both within the plan view as well as the elevation view. Cabinets may also now be lassoed and assigned different design groups in batches as opposed to selecting them one by one. So you do this by clicking and dragging a lasso over the objects in question. And then over in the attributes section, you'll have a cabinet group attribute. You can then click to select some other group. We'll create, for instance, a second group here, second group. And when you select that second group from that list, all the products that were selected will have that group changed. And you can do this within the elevation view as well. So if I were to click and drag and select the cabinet within here, I can do this both for the cabinet group and for the grade matching group directly in here across all the products within that lasso. And this will not affect non-cabinet items because it will not be relevant to them. So it's a very time-effective way to select a whole group of cabinets, reassign the design group, and therefore have a second set of global options to work with. There's now a new connection method in the construction connection section that we dubbed the Hefele cam outrigger. And so if you were to go to the templates here, you will see this new connection. It's basically the same as a Rayfix with slight differences to the diameter of the hole and the placement of the hole, and also with the addition of a dowel hole for additional stability. It will look something like this. And you configure it in much the same way. You first create the connector. Let's create this new connector here. And then determine the sizes of the holes, where they are to be placed, the orientation of the connector, and how many of them to apply across the connection that you're dealing with. So for instance, here's the cam connector hole depth, the edge offset from the center of the cam hole to the edge of your side, and then the depth of the dowel hole, diameter of the dowel hole, and the location of the cam screw hole. The cam side can then be selected to be either on the external part of a case part, so on the outside of, let's say, a side or a back or a top, or that would also behave by putting it to the top, right, or back side of an internal part, like a shelf or a partition. The opposite of this for internal or bottom left front side. Or you can tell it to orient itself based on where the finished face of the material is, either on the finished side or on the unfinished side. Next, select the arrangement for these, and this works much the same way as other boring or hole boring joints. You can either do front to rear, where you specify an initial offset and then tell it to add a hole or a connector every however many inches or millimeters. Do the same for the rear to front instead, so going from the back to the front. Front and rear, where you tell it how it should do the front holes, the rear holes, and middle holes. Or center, where you just tell it to add some set quantity of these connectors, or add one connector every however many inches. You have various ways you can specify how many of these connectors and where to add them. And once that is done, assign the CNC operation, tell it to pre-drill these holes for your CNC, and then assign the connectors so that CABuilder will keep count of how many of these cam and dowel connectors to show on your cut list. While on the topic of connections, the adjustable shelf holes have a new parameter associated with them. So if you look to your, for instance, for your shelf pin boring, there will be a new attribute called shelf bottom pocket. So this is where you enable or disable these and then specify their dimensions. The point of these pockets is so that the shelf pins can be seated within them and effectively hold the shelf from moving forward or backward. And these are, of course, very useful for angled shelves so they don't just fall off the shelf pins, but could also be enabled for normal shelves. And when enabled and specified, you can see the result within the wireframe editor. While on the topic of shelves, they also have a new hardware attachment that you could add. So if you were to go to a shelves attributes, you'll notice a new section called shoe fence. And this is where you select what we call the shoe fence. It's basically a front rail for keeping back any shoes or other objects from sliding down, which again is going to be more relevant for angled shelves than anything else. But these shoe fences can then have some pre-drilled set of holes associated with them that apply to your shelf and therefore will be sent to the CNC. Shoe fences, like any other material that makes up the cabinet, are defined within the material management section. So if you were to go to material management, select the material, they're going to be found under connectors. And their parameters include the dimensions of the 3D model, the name of the material, and then the connector section where you define, okay, here's where these holes are going to be placed relative to the center of the material. Moving on to reports and printouts, the Cutlass table has a new .xlsx export mode that can be imported into spreadsheet programs like Excel or Numbers. So simply go to the cut list, and like any other export, you go to the top left, click Export Cut List, and then choose the output file type to be .xlsx, and then hit Save, and that will download the file over to your Downloads folder. That can then be opened within any spreadsheet program, again like Excel or Numbers. Nesting results can also now be exported through .dxf. So if you go to your layout menu after you have configured and optimized your cut list, you can click at the top left Export, determine what is going to be present, sheet, part name, and part dimensions. You can toggle these on or off, the units and precision to use, as well as the text height, and then click Export. And what this will do is it will export the sheets, the layouts, the labels, and whatever else you may include in there that can then be imported into other CNC programs like Vectric or Enroute, whereupon you can customize them and assign some custom toolpaths. So it's important to notice that these are just the shapes of the parts and not the toolpaths themselves. So once you have imported into a new program, assign your toolpaths and you'll have your CNC codes. The final project we will check in this video will be the edge correction, which is relevant specifically just for CNC users. Now, sometimes you come across cuts that have inside corners, especially with pocket operations. And these inside corners generate extra material due to the nature of the CNC cutting. And you can now assign a smaller tool bit to minimize these inside corners without cutting into usable edges. This is relevant to door profiles, door pockets, and certain other connection methods. Let's start with an example. Say we're trying to make a shaker one-piece MDF door. We'll name this shaker one piece. And we're trying to just cut it out of a single piece of MDF. So that means we're going to be using a pocket tool, let's say a 3-inch flywheel, to remove this middle pocket area. And when we do that, we have these large inside corners of 1.5 inch radius, which can really mess up our corner. So we can then enable this edge correction to take care of that and minimize that radii. So let's determine the overall specs that we want for this. We'll say 2.5 width to all the styles and rails. And then we'll select the panel type to be flat. We want it to be shaker. It's not going to be a separated panel. It's just integrated into a single piece. We'll make this panel recess 1/4 inch. So our flywheel will remove 1/4 inch worth of material. And here we have a new checkbox called Enable Corner Cleaning. So when we check this on, it will enable the inside corners to be cleaned. If we leave this empty, then we'll use the default pocket clearing tool in your toolset, and we'll see very shortly how that works. But we're going to specify in this cut that we want to specifically use this 1/8 inch down cut, just to really minimize those corners, make them as sharp as possible, and give us a good look. All right, with this done, we'll save the door, assign it to our design, and send it over to the CNC. Once we have some doors and we check out the toolpaths section, we can see the main pocket passes followed by the edge correction pocket passes to clean out those inside corners. So this will clean them out, minimize the radius, and make those as sharp as can be done directly on the CNC. Importing these G-codes into NC Viewer, we can see further details. So again, here are the main pocket operations, and these 1/8 inch downcut passes will clean out the inside corner, the size of which is determined by the radius of the main pocketing tool bit. Now, as previously mentioned, if we selected that specific tool bit, then that's the one it will use. But if we did not, then we'll use whatever we have set in this new entry right here, default corner cleaning tool. So if I were to go back to the door and disable the 1/8 inch downcut and just leave it empty, the 1/4 inch downcut will be used instead, and viewing this through the NC Viewer will reveal exactly that. Smaller triangle, smaller amount of passes because we have a wider cleaning tool, that 1/4 inch downcut, while removing the same amount of pocket. Of course, the radius for this one is going to be 1/4 inch divided by 2, which is 1/8 of an inch instead of the 1/16 of an inch. So it won't be quite as sharp of a corner, but you will be done in fewer passes. The same edge correction operation can also be assigned to tool groups. So let's say we're trying to make, instead of a shaker one piece, we're trying to make a raised panel look where we have a one piece MDF door and we have some bead or cove passes that make the associated profile. Let's turn this into a raised center panel, and we'll assign to it this center panel tool group. We'll use the sample raised panel in here. What this will do is we'll make this profile by sending a bead to make this first pass and then a cove to make the second pass, but this will result in large inside corners here because the bead tool is quite wide. How can we correct this? Well, this will be done within the tool group itself. So let's head on down to the tools library and we'll check the tool groups panel associated with this, which is the sample raised panel. And let's say we want to use the 1/8 inch downcut. We go on the left, bring in the tool bit as you would a normal pass, and then define its offset and depth. We'll make the offset the radius of the bit, which will be 0.0625. We'll make the depth however much we want to remove from the material, which let's say 0.08, somewhere around there to match the profile of the bead. But this will effectively send the 1/8 inch downcut all the way around the profile. That's not what we're trying to do. We're trying to just corner clean. So we go to the 1/8 inch downcut, enable corner cleaning. And now we need to tell it how big the corner cleaning radius will be. How much material are we trying to account for here? Let's set this to the radius of the bead, which would be, in this case, a 1/4 inch divided by 2, which would be 5/8 of an inch. And when we do that, we can see the outline of the 1/8 inch bit will be dotted. So once we hit save on this, it means that that 1/8 inch downcut will only go on the corners and clean that instead of just going all the way around the profile. Let's send this to the CNC, import it into NC Viewer, and see what that looks like. Now make sure that you have enabled corner cleaning in the door panel attributes, otherwise these corner cleaning passes will not be taken into account. But once you have sent it forward, here we can see the first pass of the cove and then the bead, and then we have these corner cleaning passes by the 1/8 inch downcut tool, which will ensure those corners are as sharp as we can possibly make it. Now this is we made it to be 5/8. The actual bead itself on the outside radius would be that 5/8. But if we're also trying to corner clean the inside radius, we can do that too by adding yet another 1/8 inch downcut pass at the appropriate depth and appropriate corner radius. Now, as I mentioned before, this is also relevant for pretty much any other pocket operations associated with any connection, like rabbets, dados, even box joints have some pocket operations. Typically, you would have those T-bone corrections turned on, but now that you can clean those inside corners, you can have that selected instead. So if I were to go to any connection here, let's go to the trial through dado, you'll notice the tenon inside corner correction and notch inside corner correction each have another setting that could be enabled called corner cleaning. So when you turn it on and you leave this empty, then we'll use that default corner cleaning tool to make that happen. Whereas you can override that with some other toolbit that you select from your tool set. And when we enable this, we can enable it for also the inside corners of the tenant itself. So instead of having the T-bone correction happen or having no correction happen at all, you can assign some corner cleaning with a smaller toolbit and really minimize that radius. And if we send this to the CNC, we can see the same thing happen. Here we have the main pass of this dado being done with my dado tool, the 1/4" downcut, and then the radius, the inside radii are cleaned by my 1/8" downcut that I've assigned in this case. Now, if your default corner cleaning tool has its radius the same, equal to or greater than the pocket tool that is trying to clean after, you of course will not get too many benefits by making this corner cleaning because it won't be able to remove that extra material. So if that happens, no corner cleaning is assigned because it will not have any effect. But if it is smaller, corner cleaning is present and it will make the clean assigned. As always, you can view our release notes on our website at catbuildersoftware.com/release notes for a full list of changes. Thank you, and we will see you in the next video.